Take a second to remember we have standard form. We just talked about A, B, and C are all numbers of a quadratic in standard form. So if we look at the equation and the corresponding graph already graphed for you, we should start noticing some things. Our A value, when we look at that, it is 2. And that is a positive number, so it's positive 2. If we look at it, this parabola opens up. Interesting. We look at the y-intercept, which is given to us, and the y-intercept is 1. What's the c value in the equation? 1. Going back to grade 9, we think about increasing and decreasing. When we talk about increasing and decreasing, a negative slope is decreasing, a positive slope is increasing. But for a parabola, it's hard to tell because it does both of them. Even though the parabola opens up indefinitely to the left and opens up indefinitely to the right, if we were to put a skier, marble, whatever you want to call it, looking from left to right, we are decreasing, and then at this specific point we are flat, and then we are increasing, going uphill. So we can talk about increasing and decreasing happens in two different parts. From left to right, we are decreasing, the slope is decreasing all the way to that point. So when x is less than 1, because there's 1. At that point, the slope at that exact point is completely flat. There is no slope. After x is 1, when x is greater than 1, so from 1.0001 onwards to the right, the slope is going uphill or increasing. Cool. So let's see. Our A value, direction of opening, our y-intercept, and our c value increasing and decreasing. Let's see if we can do it here. Once again, I look at our A value, -3. This parabola opens down, which means it has a maximum or a top of 1. The y-intercept is given to us here, -2. And our c value is -2. We talk about increasing and decreasing again from left to right. It's going uphill all the way to that point, -1. So right now it's increasing when x is less than -1. And then it's going downhill past that point. It's decreasing when x is greater than -1. So let's see. It looks like that c value in standard form actually tells us the y-intercept. Those are matched up. The a value, when it's positive, it looks like it opens up. When it's negative, it opens down. So there's two key pieces of information. Let's see if it holds true with the next two examples. When I take away the color coordinating, let's see. Our a value, 3, direction of opening, up. The y-intercept, -5. The c value, -5. Hey, there's no bx value. That's the letter B. That's okay, because that just means that the actual number for B is 0. And 0 times x is 0. We don't need to show that. We don't need to say all the things that aren't there. So we got a value of 3, it opens up, a y-intercept of -5, the c value is -5, and then we talk about increasing and decreasing. So we have decreasing when x is less than 0, and then increasing when x is greater than 0. From left to right, what our x values are. So if x is minus 8 over here, it's still on the slope on the parabola coming downhill. If we look at this one, our a value, negative 2, and it opens down. Negative opens down, positive opens up. We look at our y-intercept 2. We can put y equals, or because it's mentioned y-intercept, we don't necessarily have to put y equals. And our c values 2. Hey, every time they've matched up, we can probably write that in stone. Increasing and decreasing from left to right, it's going uphill. So it's increasing when x is less than that middle point, 1. And then after that, it is decreasing when x is larger or greater than 1. So by filling this out and seeing the connection, hopefully there's some things that we can consolidate. Look at the next page. Those key features in standard form, direction of opening. If a is greater than 0, which is a nice way of saying if it is a positive number, the parabola opens up. If a is less than 0, which is a nice way of saying if a is a negative number, the parabola opens down. The y-intercept is a point there. It's still an ordered pair, and it's written as 0y. But remember, it is the c term when the quadratic is in standard form. Now the point we didn't talk about is this middle point, the max or the min. That middle point is called the vertex. Right there. It's still a point. In this case, negative 2, negative 2. It provides the graph's maximum or minimum point, and we're looking at specifically how high or how low. So we're looking at the y aspect of it for the max or the min. And we decide if it's opening up, it's a minimum. If it opens down, there's an actual top, so it's a maximum. It's the point where the graph changes direction from increasing to decreasing or the other way around. Part of that, which isn't listed here and I want you to add, is called the axis of symmetry. Let's call it 2 m's. Sometimes called the AOS. And this is specifically now the x-coordinate of the vertex. It's a hypothetical line that goes right through the vertex where the left side is a mirror image of the right side. In grade 10, we only talk about parabolas that open up or open down. Y equals x squared being our standard or starting point of a parabola. Okay, so the last key thing, when we look back to the first 2 pages, the parabola opens up if the second differences are positive. There's another way to tell, not just the a value, but if the second differences are positive. The parabola opens down if the second differences are negative. And that's a parabola or a quadratic in standard form. Parabola is the actual shape. The equation is a quadratic. And now you have all the tools you need. The next page is some fun stuff. After that, you can start the homework.